Hey, so today we're going to look at the problem set from Lesson 1 in Module 2 in the Eureka Math Engage New York math curriculum for 7th grade. And Lesson 1 is called Opposite Quantities Combined to Make Zero. And the whole idea is if you have two numbers that are the same distance from zero on the number line, but they're opposite sides of zero, so like -4 and +4, or -7 and +7, or -2.1 and +2.1. When you add these numbers together, you always get 0. So like -7 plus +7 is 0. And because those pairs of numbers do that, we give them a special name. We call them additive inverses. The word inverse kind of means opposite, so you could think of them as opposites when you add. And that's why sometimes people just, instead of saying additive inverses, they'll just call them opposites. That's another name for these. So this whole problem set is mostly going to be about numbers adding up to 0 and looking at additive inverses. Problem 1 says you have two cards with a sum of -12. What two cards could you have? So you don't have to draw the little cards like I'm going to, but I'm just going to. And so I could have -4 and I could have -8, because -4 plus -8 would be -12. And then it says you add two more cards to your hand, but the total sum of the cards remains the same. It's still -12. So it gives some different examples of two cards you could choose. So if I add two more cards to my hand, but the sum doesn't change, then the two cards that I added to my hand must themselves add to 0, or in other words, be additive inverses. So if I had these two cards and then I added a 6 and a -6, then these two things would add to 0, and so if I had them with these two cards, my sum would still be -12. Or maybe I have the 3 and the -3 card. Then these two things are additive inverses, they add to 0, so if I had all 4 of these in my hand, I'd still have -12. And one more, I could have the 5 and the -5. Any two numbers you choose there, as long as they're additive inverses, will work. And so number 2 says choose one card value and its additive inverses, and then choose from the list below to write a real-world story problem that could model their sum. So maybe I have the 7 card, and then maybe I have the -7 card. Those are additive inverses of each other. And so I'm going to write a question about money. How about credits, debits, deposits, withdrawals? I don't know. We could just talk about somebody getting money and spending money. That's all this means. When you're credited money, that just means you get money, and when you debit money, it takes it away. Same thing with you deposit money into the bank, you're getting money. When you withdraw money, you're taking it out. So we can make it much simpler than that, though. Let's see here. Random name, Matt. I don't have any students named Matt this year. Matt gets $7 from his aunt. So that's like a credit. He's getting a positive $7. He spends all $7 on, what would he spend it on? Oh geez, what is it today? Fortnite skins? All right, let's go with, he spent it on Fortnite skins. In a few years, if you're watching this video, it's gonna seem really lame. Okay. And then I guess the question would ask, how much money does he have left? And you would solve this problem by doing 7 minus 7, you would get 0. And 7 minus 7, that's the same as 7 plus -7 equals 0. So we're modeling the additive inverse relationship between these two numbers. Okay, number 3. On the number line below, the numbers h and k are the same distance from 0. Okay, so we have this number h and this number k. They're the same distance from 0, but they're on opposite sides of 0. So one's negative and one's positive. That means by definition they're additive inverses. I don't need to know anything about what number h actually is, whether it's -3, -4, -5, whatever, and k is +3, +4, +5, doesn't matter. By definition, they're on opposite sides of 0, and they're the same distance from 0. That makes them additive inverses. And so no matter what h and k are, if you add them up, you will always get 0. And so it says, write an equation to express the value of h plus k equals 0. You should write a little short explanation. I explained it in words. Write what I said. During a football game, Kevin gained 5 yards on the first play. So we're on number 4 now. Then he lost 7 yards on the second play. Okay, so gaining 5 yards, it's like a positive 5. And then lost 7 yards, that's like negative 7. It's like adding negative 7 yards to your situation. How many yards does Kevin need on the next play to get the team back to where they started? So where you started would be 0, like you have gained or lost no yards. So when I do 5 plus negative 7, I get negative 2. And so I want the additive inverse of negative 2. So negative 2 plus positive 2 equals 0. This positive 2 would get them back to where they started. So I'm going to write a little conclusion. He needs 2 yards. All right, last one. Write an addition number sentence that corresponds to the arrows below. I'm not really big into the term number sentence. Seems to me like every time the book uses the word number sentence, you could just use the word equation and say what you need to say. So the arrows start at 0, and then I'm going to follow this main long one all the way over here to 10. So it looks like the first arrow is representing a positive 10. And then we're moving back on the number line, left 5 spaces to go from 10 to 5. And moving back on the number line, or to the left on the number line, I should say, that represents the addition of negative numbers or the subtraction of positive numbers, whichever way you like to think of it. But this lesson's more about addition, additive inverses, so I'm doing everything with addition. Then from positive 5, we move to the left on the number line 5 more spaces to get back to 0. So I'm going to add another negative 5. And since the arrows end at 0, I know that the sum is 0. So 10 plus negative 5 plus negative 5 equals 0. There's my equation, and I'm done. All right.